Hello and welcome to Compassion. In this video, I will be explaining you about NMR signals. What information do we get from NMR signals? So NMR signals generally gives us four important information. The first one is number of signals shows how many different kinds of protons are present in the molecule. That means how many chemically equivalent protons are present and chemically non-equivalent protons are present. Second thing is the position or location of signals that tells us how protons are shielded or de-shielded in the molecule. Third important information which we get from NMR signal is the intensity of signal tells us the number of protons of that type. So if we have similar kind of protons or chemically equivalent protons, they are going to give a signal with higher intensity. And the fourth factor is signal splitting, which shows the number of protons on adjacent atoms. So whatever signal we get, that splits up either into doublet, triplet, multiplet, or sometimes it doesn't split up, it remains a singlet. So that depends upon the number of protons present on adjacent atoms. So these information we get from NMR signal, and with the help of this we can find out structure of an organic compound. So what like number of signal and area of peak, what does it indicate? So number of signal indicates chemically non-equivalent protons. So if we have four signal, that means we have four sets of chemically non-equivalent protons. And the area of peak indicates number of protons responsible for the signal. This is also called as proton integration. Suppose we have this NMR spectra for this particular molecule. So here you can see that we have methyl groups. These two methyl groups are their surrounding is same because both of them are attached to carbon atom and this carbon is attached to OH group. So these two methyl protons are chemically equivalent protons. So both of them all together will give one signal, and since there are total 6 proton, 3 plus 3 6, so the intensity of that signal would be very high. So these methyl proton are shown over here uh, showing maximum intensity. This methyl proton denoted by B, it will give a signal over here near delta 2. So these methyl protons are non-equivalent or they are not identical to these because their surrounding is different. And this is showing a proton integration of 3, means the signal is because of 3 protons, so its intensity is lesser as compared to first signal. Then we have methylene proton, which is totally different from methyl groups. So they are going to give this third signal, and its intensity is still lower because that signal is due to presence of 2 protons. And then we have OH proton, hydroxyl group. So its intensity would be least. So these number of signal, here you can see we have 4 signals, indicates 4 different types of protons present in the molecule. And area under these peaks can help us in finding out that that particular signal is because of how many number of protons. So let's understand how to find out chemically non-equivalent protons. So these are few examples. Here if we see, this is bromopropane. We have CH3, CH2, CH2. So methyl is totally different from methylene group. So these 3 protons are first set of proton, which is denoted by letter A. They will give one signal. We have 2 methylene groups. This second carbon atom is attached to one methyl and CH2, and this third carbon atom is attached to bromine and CH2. So these two methylene groups are chemically non-equivalent because their surrounding is different. So both of them are going to give different signal. So total number of signal for this particular molecule is 3. If we take 2 bromopropane, here you can see that we have 2 methyl groups and both of these methyl groups are attached to CH. So their surrounding is same. That means these 2 methyl groups are chemically equivalent. So both of them will give one signal denoted by A. And then we have methine group CH, which is different from these methyl groups. So that is going to give second signal. So total number of signal is 2 signals. Then we have ethoxymethane. In this case, we have three different kinds of proton. This methyl group and this methyl both are chemically non-equivalent because this methyl is attached to carbon atom while this particular methyl group is attached to oxygen atom. So both of them are going to give two different signal, and third signal would be because of this CH2 group. So total number of signal is 3. Then we have diethyl ether. This here both methyl groups are identical. They are chemically equivalent. So they are going to give only one signal. In this molecule, you can see that there are total 4 methyl groups. Out of these 4 methyl groups, these 3 methyl groups, they are attached to same carbon atom. So these 3 methyl groups are chemically equivalent. So all 3 of them are going to give one signal whose intensity would be very high because of total 9 protons, 3 plus 3 plus 3. While this methyl group is going to give another signal because it is attached to oxygen atom, so this is non-equivalent. So total number of signal is 2. This carbon atom which is present at the center is not going to give any signal. Why? Because on this carbon atom there is no proton attached. So to get any signal, there has to be some proton attached to the carbon atom. If there is no hydrogen attached to carbon, you will not get any signal. If we consider this molecule, it is vinylic compound. You can see here protons are attached to this carbon atom and we have these methyl groups. So these two methyl groups are chemically equivalent. They are going to give same signal, and these two protons are attached to same carbon atom. So that will give second signal. So total number of signals is 2. If I consider this molecule, you have 3 protons and all these 3 protons are different. So we are going to get 3 signals. Now you might be thinking that over here to this carbon 2 hydrogens are attached, they are giving same signal, while in this molecule these 2 hydrogens are giving different signal. So what is the reason behind that? So here if you see, this proton is trans with respect to this bromine, while this proton is cis with respect to bromine. So their surrounding is different, and that is the reason both of them will give different signals. So first signal, second signal, and this proton is different or non-equivalent, so that will give 3 signals. If we consider this molecule, whether I check this proton, here both methyl groups are there, so these are identical. That is the reason both of them will give same signal. If we take benzene, it is highly symmetrical molecule, so all the protons of benzene are identical, so all of them will give only one signal. When we put some substituent on benzene ring, then the proton becomes non-equivalent. So here we have nitrobenzene. Now these two protons are ortho with respect to this nitro group, so they will give one signal. These two protons are meta with respect to nitro, so they will give second signal, and this is para, so 3 signals. So these were few examples. Let's check few more examples. So here if you want, you can pause the video and try to solve these examples, and later on you can check whether your answer is correct or not. So if we see first molecule, this is dibromoethane. It is a symmetrical molecule. I can break this molecule into two identical halves. So these two methylene groups are identical, so both of them are going to give one signal. So over here I have one signal because it is a symmetrical molecule. In the second example, here you can see this CH3, there is only one CH3, so that is going to give one signal. Then we have three CH2 or methylene groups. All these three CH2 groups are different. Why? Because this CH2 is attached to oxygen and then one carbon atom, so that will give second signal. This CH2 is attached to CH2 and O, while on the other side it is CH2Br. So that will give you third signal. And this CH2 is attached to bromine and on the other side CH2 group. So that will give fourth signal. So total number of signal for this molecule is 4. If we consider this third example, over here we have total 4 CH2 groups. These are the 4 CH2 groups, and it is again a symmetrical molecule. I can divide this molecule into identical halves. So over here, when you check the surrounding of all four of these methylene groups, all of them are identical. So they are going to give one signal. In fourth example, we have total 3 CH3 groups. So out of these 3 CH3 group, these 2 CH3 which is attached to carbon atom, they are chemically equivalent, so they will give one signal. This middle carbon to which bromine is attached, that is not going to give any signal because there is no proton attached to that carbon atom. Then we have CH2. So this CH2 will give you second signal, and then another CH3 that is going to give you third signal. So total number of signals are 3. For this last one, we have 2 CH3 group and 1 CH2 group. Both these CH3 groups are chemically non-equivalent because this CH3 is attached to CO and this CH3 is attached to oxygen. So we have total 3 signals for this particular molecule as well. Let's see a few more examples. Now this example, first example I had already discussed. Let's see one more time. Here we have total 3 different types of protons. So this is your first proton. These two protons, these two are different. Why? Because this proton is trans with respect to chlorine, while this proton is cis with respect to chlorine. So they are different. So they are going to give different signals. So total number of signal is 3. Next example, it is symmetrical molecule. I can break this molecule into 2 identical halves. So you check the uh, chemical equivalence on one side. Those many signals will appear. So we have total 2 signals in this molecule. Whenever you have symmetrical molecule, you break it into half and check one half of the molecule and see how many signals will appear. In next example, we have CH3, so that will give one signal, and then 2 CH2 groups are there and their surrounding is different because one CH2 is attached to oxygen and other CH2 is attached to chlorine. So we have total 3 signals. Next example, again here you can see we have 1, 2 and 3 signals. If we see this molecule, where we have heterocyclic ring containing oxygen atom. So here these two CH2s are same because both of them are attached to oxygen, and this CH2 is different because it is attached to 2 carbon atoms. So over here we are going to get total 2 signals. I hope you are getting this. Let's see few more examples. In this, you can see 2 CH3 groups are there. Both of them are attached to same carbon atom, so they are going to give one signal. This CH, now on this carbon, one proton is attached, so that will give you second signal. CH2 will give you third signal, and this CHO, because aldehydic proton is there, so that is going to give you fourth signal. So total number of signals are 4. Now again we have got a symmetrical molecule over here. This is a symmetrical molecule. So these CH3 are going to give you one signal. These two CH2s are going to give you second signal, and middle CH2 is going to give third signal. So total number of signals for this molecule is 3. Over here you have a vinylic molecule. 2 hydrogens are there, CH2 group is there. If you consider this hydrogen, this is cis with respect to this chlorine and trans with respect to this chlorine. Same is the case with other hydrogens. So both are identical. So over here you will get one signal. In next example, these two hydrogens are identical. They are chemically equivalent protons. Why? Because the hydrogen is cis with respect to chlorine and trans with respect to this hydrogen. In both the cases, it is same. So we get one signal. And last molecule, as I said, it is a symmetrical molecule. All CH2, it is cyclopentane. So all CH2 groups are there. So together they are going to give one signal. So this is how we find out uh, total how many signals will appear in NMR spectra and chemical and non-equivalence of protons. I hope you like this video. Thank you so much. Please like, share and subscribe.